Welcome students. Now we are going to see exercise 1.2. The first sum, prove that root 5 is irrational. First of all, we must know the definition. We already know that. What do you mean by irrational number? The number which cannot be written in the form a by b. Then it is called a irrational number. If it is written in the form a by b means then it is rational number. In this exercise we are going to prove in a contradiction method. That is, if they given prove that root 5 is a rational number means we are going to take this as a rational number. So after doing some step we arrive at some contradiction to the trivial factor. That trivial factor contradiction arises because our assumption is wrong. Then we can say our assumption is wrong, so this must be a irrational number. So in the way we are going to prove. So first we have to take the contradiction assumption. That is, let us assume to the contrary that root 5 is a rational number. Root 5 is rational. We know that the definition of rational, if it is a rational number, then it can be expressed as a form a by b. So we can find integers, some integers. Let us take, I am taking p and q, such that the q not equal to 0, such that, so we can write root 5 as, if it is a rational number means we can write p by q, where q not equal to 0 and p and q belongs to z. This is in the notation form. This is, we are writing that. Then what we are going to do is, if p and q, suppose we are writing p and q, some integer, for some integers we are writing p by q. Suppose if they have common factor, we can divide that factor. So suppose p and q have common factor other than 1. If it is one common factor means there is no need to divide. So if the common factor, if it is have the common factor other than 1, then we can divide. Then we can divide them by the common factor. So after dividing the common factor, we have to assume that. Now we assume that. We have to take the same integers. P and q have the common factor 1 alone. So if the p and q have common factor 1 means, what it means? P and q are co-prime. The definition of our co-prime is they have the common factor as 1. So we are writing the common, if it is have the common factor other than 1, we are dividing. So after dividing, we have the common factor 1 alone. So then 1 alone means p and q become co-prime. So p and q are co-prime. So co-prime means we already know that root 5 equal to p by q. So we can write p equal to root 5 into q. So now we can squaring on both sides. Squaring, we get root 5 square means 5. So 5 into q square. So this implies what it implies? It implies p squared is divisible by 5. We can write up as it is, p squared divisible by 5, or 5 divides p squared. Anyway you can write p squared divides divisible by 5 you can write, or 5 divides p squared you can write. Now I am going to write 5 divides p squared, because in the theorem we are having divides term only. That's why I am writing 5 divides p squared. So by theorem, we already studied the theorem 1.2. What it says, theorem 1.2 says 5 divides p squared. If a prime number divides p squared means then it divides p also. So by the theorem 1.2 we can write 5 divides p also. So if it is divides p means, so we can write what we can write, p equal to 5c for any integer c. For any integer c. So now we are going to substitute p equal to 5c in this term. We can mark it as 1. So substitute in 1, it becomes p, you can write p for 5c square equal to 5q square. So 5c square is nothing but 25c square equal to 5q square. So we can cancel. So this become 5. So we get 5c square equal to q square alone. So what it implies, we already know that if p squared equal to 5q squared means then 5 divides p squared. In a similar way, we are arriving at 5c squared equal to q squared. Then 5 divides q squared. So 5 divides q squared. So by the theorem 1.2, we can write 5 divides q squared means then it divides q also by theorem 1.2. So if 5 divides p and 5 divides q means what it means? 5 divides both p and q. 5 divides p and 5 divides q. What it means? 5 divides both p and q. If 5 divides both p and q means then 5 is a common factor. Common factor for p and q. We assume that what we have assumed, p and q are co-prime. Co-prime means that have common factor 1 alone. But we are arrived at the contradiction that 5 is a common factor of p and q. This contradiction arises why? Because of our wrong assumption. What is our wrong assumption? Root 5 is a rational number. So we arrive at what we arrived. 5 is a common factor for p and q means what it become? P and q are not co-prime we are arriving. P and q are not co-prime. So this contradicts our assumption that what we have assumed p and q are co-prime. So this contradiction arises. Why this contradiction arises? This contradiction arises because of our wrong assumption that root 5 is a rational numbers. So we can conclude that root 5 is irrational number. Root 5 is irrational. So once again I have to recall this problem. First they have given root 5 is irrational. I already told that we are going to prove this problem by the assumption of contradiction assumption. So let us assume that root 5 is rational. We know that if it is a rational number means we can write it is in the form of p by q. So suppose p and q have common factor mean other than 1 means we can divide them, and we also assume that p and q are co-prime. Co-prime means it have the common factor 1 alone. So we can write p equal to what we can write, we can go root q here. So p equal to root 5q. Squaring on both sides, p squared equal to 5q squared. So this implies 5 divides p squared. By the theorem 5 divides p squared means 5 divides p. So we can write phi equal to 5c for any integer c. Now we have to substitute p equal to 5c in 1. So 5c the whole squared equal to 5q squared. So squaring on both sides, 25c squared equal to 5q squared. We can cancel. So we get 5c squared equal to q squared. So 5 divides q squared means by the theorem 5 divides q. So now we arrive at 5 divides p and 5 divides q. What it means? 5 is a common factor for P and Q. So 5 is a common factor for P and Q means then it becomes P and Q are not co-prime. So this contradiction our assumption that P and Q are co-prime. So this contradiction arises because our wrong assumption that root 5 is a rational number. Root 5 is a rational number. So we can conclude that root 5 is irrational. Thank you.